Welcome to the Boolean Algebra Introduction course. We're going to talk about the objectives here, and for those of you that remember your school days and going into a pure panic and set of fear with the mere mention of the word algebra, you don't need to worry. In this case it's actually not too bad. What we're going to do is we're going to introduce the basic operations and the derived operations, and give you some examples to see how they can be used in a real-world computing environment. So what exactly is Boolean algebra? Well, it's a formal way of specifying or describing a particular situation or procedure. To do this we use variables to represent elements of the situation or the procedure. Variables in this case can only have two values, which is typically true or false. However, for convenience in computing, we often refer to them as 1 or 0, with 1 being true and 0 being false. So let's have a look at a quick example. How would we represent if it is raining in Boolean? I don't mean in the place, I mean in the mathematics sense. We would say true if it is raining. We would say false if it is not raining. In reality, of course, there are many different degrees and levels of rain, but in Boolean it is either black or white. Now this may seem very limiting to you, but actually this simplification can be very, very powerful when representing all sorts of different things, and can be used in very complex situations. So we've seen now that variables may be used to represent the current state of the elements we're interested in. However, operations allow us to define relationships between those variables, and in Boolean algebra there are three basic operations which we'll come on to as the slides progress. These Boolean expressions are often used to create far more complex operations, and remember, the result of an operation is similar to variables. It may only either be true or false, 1 or 0. So we'll come on to the first, and that is called AND. And it's pretty much what it says on the tin, really. For instance, I may state, if it is sunny outside and I've completed my work, I will go for a run. So to represent this in Boolean, I may say X represents if it is sunny or not. Y represents how I completed my work or not. And Z would represent if I go for a run or not. So look at the slide and you can see it is written X and Y equals Z. Now for convenience and to help save confusion when documenting things, we normally write the Boolean expressions in uppercase. That just makes reading easier for people. So here we use what's called a truth table, and that helps us visualize pictorially what's going on. Now in simple cases you think, well, do I really need that? Probably not. But as expressions and operations become far more complex, it's very easy to get lost in them, especially when you've got some embedded in parentheses or brackets and you've got a whole load of them. And it makes it easier sometimes for you to just get your head around what's going on by drawing up a truth table. So that's an example of a truth table for AND. Now to help me remember AND, I always think of mathematics multiplication, which is really quite simple. Anything multiplied by 0 is 0. So as we can only have 0 or 1, the only time you'll get a true result of 1 is when they are both. Now with or, again, it's what you would expect from the English meaning. It means if either of the two variables are true, then the result is true. So for example, I'll get home from work early either if I leave early or if the traffic is good. And again, that can be represented quite easily and quite neatly using a truth table. Now, to help me remember or, I think of addition. However, of course, if I was applying pure mathematics, 1 plus 1 does not equal 1. But for the purposes of the fact you can only have 0 or 1, you get the idea. And see the truth table to the side for the examples. Now for a good one. It's called not. Go on, have a guess as to what that means. It simply means invert the value. So if it was true before, it becomes false, i.e. not true. If it was false before, it becomes true, or in other words, not false. However, this is no different to real life. Simple things can't cover every single possible conceivable thing that we can think of. Sorry for the sun there, but being in England, it's not often we see the sun, so I'm quite grateful. It was snowing earlier today, and it's summertime. So anyway, getting back to the point, we need to use derived operations, and they help us just take things to the next step. Derived operations are only used for convenience. Anything that we use a derived operation for could actually be done using the basic operations, but for convenience we use a derived one, which we'll go into over the next few slides. As I've just said, they're used for convenience. They're shortcuts. And that is pretty much it. However, they are useful when we're doing computational things, and as I say, some of them can get very, very complicated. So we use them for simplicity's sake only. So now we've covered a good introduction to basic Boolean. I hope it's helped you understand it, and I hope it's removed any of the fears that you may have had at some point about particularly the term algebra, if nothing else. You can contact us using the URL at the side, and if you go to the wiki, of which there should be a link on the bottom of the slides throughout the presentation, there's other material available and we cover other topics. Thank you for your attention, hope you've enjoyed it, and please check out some of the other videos that we have on the site covering various parts of computing, some of it theoretical, some of it will be how-tos. The site's constantly growing, so there is no definitive answer to that. Enjoy, goodbye, and thanks for listening.